Good morning, dear students. In today's class, we will study about the periodic table. The periodic table is very important to know the elements, to know the element group, to know whether that element is a metal or non-metal, to know the particular element belongs to which block. So that's why to study these elements and their properties like chemical property and the physical property and everything, this periodic table plays a very important role. So that's why in this video we will see the brief introduction about the periodic table. So first of all, to say about periodic table, so periodic table is consists of four blocks. We already know those are S block, P block, D block, and F block. So how these blocks are divided and how they are separated in the periodic table, we will see one by one. So first let me explain just a rough diagram of periodic table. So thus one we can come to know how this periodic table looks like. So this is the rough diagram. So in this rough diagram, one we can say in the left side which block is present, in the right side which block is present, in between left and right which block elements are present. So we can decide now. Say for example, this is S block. That means all the elements which comes in this part, those belongs to S block. And here in the right hand side, this consists of P block elements. And in between S and P, there are D block elements, and those are called as transition elements. In the next year, in the second year, we come to know. And at the bottom of the periodic table, you might see two horizontal rows, and those belong to F block elements. And these F block elements are divided into two series. One is lanthanide series and other one is actinoid series. So in the same way, here what we come to know is how the periodic table in actual looks like. So now, after seeing this rough diagram, in periodic table, we come across the periodic table is mainly divided into two parts. That is, those are groups and periods. Very important. Groups and periods. So what are groups? What are periods? We will come to know now. So first of all, the periodic table is separated into two parts. Those are groups and the periods. In a periodic table, there are 18 groups, right? There are 18 vertical lines, we can say, right? Vertical lines, from up or down, you can say. There are 18 groups in the period or periodic table, and there are 7 periods. That means horizontal rows. The horizontal rows, that means from left to right. If we move in the periodic table, if we move from left to right, then that is called as period. If we move from top to bottom, then that is called as group. This is very important. So what is the use of these groups and periods? We will come to know later. But first of all, what we saw till now. So periodic table is divided or categorized into two different parts. Those are groups and periods. So groups are 18 and periods are 7. So group is nothing but vertical line and periods are nothing but horizontal row. Here again, if we see the periodic table till now, we know 118 elements till now. Among 118 elements, still the searching is going on. So that means we are getting new elements, but till now we know 118 elements. Among those 118 elements, the gases are, right, there are approximately 11 or 12 gases elements. Those are all the zero group elements like helium, neon, argon, krypton, xenon, radon, oxygen, nitrogen, hydrogen, and we can say fluorine. These are the what I mean gases, or else you can say chlorine. Likewise, you can say these are among those 118 elements. These are the gases. One or two elements I left, I don't know, but these are the gases. And next, liquids are like francium, cesium, bromine, gallium, right? Gallium, and very important one more, mercury. And now this element is very important. First of all, bromine is a metal and which is liquid. See, bromine is in the whole periodic table. If you see, bromine is a metal. In general, what we say is all the metals are solids, but not in case of bromine. Bromine is a lonely metal which is liquid, and rest all are, except these elements, rest all are solids we see in the periodic table. So now we continue our groups and period, right? So as I said, there are 18 groups and 7 periods. So these 18 groups are, these 18 group consists of different block elements. That means first A and second A groups consists of S block element, right? Next, these blocks also consists of P block element as well as D block element, and even finally in the bottom we can see F block elements also. In the period, that means in the 7 horizontal rows, we see different family elements. So later in the detail, if we study about the periodicity chapter, there we will see. Here I will just give you an introduction, right? So now after knowing these all those properties, finally one we came to the one conclusion that there are 4 blocks, and those 4 blocks are, again I will write S block, P, D, and F block elements. So that means now we will see what are S block elements, what are P block element, D and F block elements. This is very important. So till now we saw a periodic table. They are categorized into 2 parts. Those are group and periods. And then later what we saw in group, period, and in group we have 18 groups, and period we have 7 periods. So among those 7 periods and 18 groups, what we saw is there are 4 blocks. That means the whole periodic table is categorized into 4 different blocks. Those are S block, P, D, and the F block. That means what are those blocks? First we will see what is S block element. That means before going to S block, I will define what is now. I will define what is how the periodic table is in periodic table how the elements are arranged. So in periodic table, the elements are arranged based on their physical property, chemical property, and very importantly based on their electronic configuration. In the last class we saw this how to write. I think now you can write electronic configuration very easily. So this periodic table, in the periodic table, the elements are arranged based on their physical property or chemical property or based on electronic configuration and their metallic character, non-metallic character, metalloid character, electronegativity character, and the noble gas character. Based on that, these elements are arranged. So now, how to identify or what is S block elements? So S block element is nothing but, see, if the last are the differentiating electron, that means, say for example, we will take one example, that is hydrogen. Or hydrogen is very easy. We can identify which block element. So we will take example as lithium. So lithium, whose atomic number is 3, and if I write the electronic configuration 1s2, 2s1, right? See here, in the last video during electronic filling rule, what I said, while writing the electronic configuration, we have to consider most importantly how many number of electron we have with our element. In this particular lithium, we have 3 electrons. So that's why what I did is the capacity of S subshell is to take 2 electrons. So that's why 2 electron with the lower energy, and I moved into the second cell, right, according to the Pauli's exclusive principle or Aufbau rule. So now after that, after putting or filling these 2 electron into the 1s cell, 1s cell is completely filled now. So now after 2 electron, 1 more electron left with us. So that's why that electron will move. That means this electron, I can call this electron as what? Differentiating electron or last electron, right? So why we are calling this electron as a differentiating electron means this electron plays a very important role to decide whether that the particular element is S block element or P block element or D block element or else F block element. So that's why in this lithium, right, before writing the electronic configuration, we didn't know lithium is which group element, so or which block element. So that means after writing the electronic configuration with respect to the definition, what is the definition? If the differentiating electron or the last electron enters into the S subshell like this, S subshell, then those elements are called as S block elements. Very simple. So that's why this differentiating electron plays a very important role. If the last electron enters into the S subshell, then those type of elements are called as S block elements. Again, we will see one more example, that is sodium, and sodium atomic number is 11, right? So now we have how many number of electrons? 11 electrons. So now while writing, be careful the number of electrons, about the number of electrons. So now 1s2, 2s2, 2p, see, we have totally 11 electrons. So 11 means already 4 electrons are in 1s and 2s. That means how many electrons are left? Again, we have 7 electrons with us. So what is the capacity of P to move third level? 6. So that means we have enough number of electrons. So one we can completely fill this P. And then see now 6 plus 4, 10. How many electrons are left again? 1 electron. So that means our electronic configuration will move up to third set. So now again, the last electron, very important again. So the last electron is entering into the S subshell again. So that's why for sodium also, if somebody asks you sodium belongs to which group, means simply we can say S block element. Based on what? Based on the electronic configuration, or based on the what? Differentiating electron. So this differentiating electron is entering into the S subshell. Either it may be a first S, either it may be a second S, third S, 4s, no matter. If it is entering into the S subshell, then it is called as S block element. So these are nothing but the S block elements, right? So now we will see the P block or P blocks. How? And some examples. P block. So P block elements are nothing but again the same definition. Like if the differentiating or the last electron enters into the P subshell, then those are called as P block elements. Let us take example like boron, carbon, boron, carbon, nitrogen, oxygen, fluorine, neon. This is the noble gas. So boron, carbon, nitrogen, oxygen, fluorine, and the neon. So these are the some examples. So take one example like carbon. So whose atomic number is 6, we already know. And the electronic configuration is 1s2, 2s2, 2p2. I am writing directly. Why? Because already we saw the electronic configuration of carbon in the last video. Now, the total is 6 electrons are there. So that's why I have filled in their respective suborbits with the energy levels, with respect to the energy level. So now here the last electrons are entering into the what? P subshell. So that's why the carbon is a P block element, right? So in the same way we can say nitrogen 7, right? So these two are same. That means increase only 1 electron. That means here also the last or differentiating electron is entering into the P subshell. So that's why nitrogen will also belong to family called P block, right? And again we can take one more example, 8, right? So oxygen 8, increase 4 plus 4, 8, 4 plus 3, 7. So therefore again the differentiating electron is entering into the P subshell. So that's why this type of elements are called as P block elements. So next is D block elements. So the D block elements are very important for the second year classes. So that's why this is the basic thing to understand what are P block D block elements. So D block elements again, what we can say is if the differentiating electron enters into the, or the last electron enters into the D subshell, then those are called as D block elements. See, for D block element you can say scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, like this, right? So I took three or third D block, right? So here we see, by taking one or two example, we will see. First, take scandium. So scandium is atomic number of scandium is 21. So therefore, in the last video we saw the same electronic configuration argon. Argon is a noble gas which is very near to the scandium. So that's why whose atomic number is 18. That means among 21 electron, 18 electrons are already filled. Now we have only 3 electrons. So that means after 3p6, we directly enter into not 3D, we directly enter into the 4s. Because we have 3 electrons, that's why I am directly filling this S of 4th cell. So now after 4s, we come with 3D. And how many? See, 18 plus 2, 20. We have 21, so that's why I am moving to the D. Now, the last electron is entering into the D subshell, so that's why it is called, or this element belongs to which family? D block, right? In the same way, we can say titanium 22, right? Again, same, argon 18, 4s2, 22 means 20, and now 1 is left, that is 3d2. Likewise, vanadium 23, again the last electron is entering into the same subshell, so that's why titanium is also belong to what? D block. So argon 4s2, 23 means 3 electrons are left. Like this, the last electron or the differentiating electron enters into the D subshell, and then those elements are called as D block elements. In the same way, F block element is also same. So that means if the differentiating electron enters into the F subshell, then those are called as F block elements. I am not going in detail about F block. Why? Because we have separate topic in case of second year. So that's why still some doubt may come if I write the F block element electronic configuration. So that's why I am not explaining that, right? So now after seeing all these things about periodic table, right, about group and periods and all, now the very important things are atomic radius, next electron affinity, next electronegativity, right, metallic character, non-metallic character, so these things are very, and most importantly one more is ionization energy. After having the introduction about the periodic table, these things will play a very important role. If you come to know what are these things, then it will be very easy for us to how to write the chemical reaction, and what is the oxidation number of element, and one hydrogen can react with how many number of oxygen, or one oxygen can react with how many number of hydrogen. These all questions will be uh, clear by seeing these things. So that's why this part is for me, which is very important as a basic. So that's why atomic radius plays a very important role to know what is the size of atom, a particular atom, and how this radius is nothing but size. So that means how this atomic radius changes in period and in group. How the in period, whether the atomic radius increases, that means the size of element increases or decreases, or in group also, how the atomic radius varies, right? So we will see now. Before going to these atomic radius, by taking atomic radius in period and group, we see first what is atomic radius, or the definition of atomic radius, right? See, in the first class I said atom is a very smallest particle. It will not undergo further into the division, or we cannot divide, or we cannot break this atom. Why? Because it is the smallest particle. So atom means it must and should contain nucleus, right, and the outer part, that is electrons. Very important, right? So if there is an atom, these are the basic things. In nucleus we have proton and the neutrons. So that is the very well known thing, right? So now I will take one example to understand this atomic radius. Say for example, we will take lithium, whose atomic mass or number is 3. So 1s2, 2s1, right? Consider lithium is an atom. Atom means there should be a nucleus and then the cells, right? 1s2 and 2s1, right? So I can write clearly here 1s2, and this cell is of second, that is 2s1. The total difference, now definition about the atomic radius, the total or the complete distance between nucleus of the atom to the outermost cell, right? So the distance between the nucleus or the center of the nucleus to the outermost cell. Say for example, outermost cell may be a single, like in case of hydrogen 1s1. That means what is the atomic radius of hydrogen? This much, right? If sodium means 3s1, that means take an example, sodium, consider sodium 1s2, 2s2 to be 6, 3s1, right? So what is the atomic radius? That means the distance between center of the nucleus to the outermost cell, not this cell or this cell, the cell which is outermost. The distance between the center of the nucleus to the outermost cell is called as atomic radius. Very simple. And this atomic radius will explain everything about other property, other things, ionization energy, electronegativity, metallic character, non-metallic character, right? So that's why this atomic radius is very important. Try to understand it. So again, once again, I will repeat. Atomic radius is nothing but the distance between the center of the nucleus to the outermost cell is called as atomic radius. So how this atomic radius, now we will go with our period and the group, right? So I will remove this now. So we will see our atomic radius in case of group. So we came to know what is atomic radius. Now we will see our atomic radius in group. So I already said groups. How many groups? There are 18 groups. Group is nothing but top to bottom, right? If we move in the single vertical line from top to bottom, then that part is called as group. So I will show you one group. That means, see, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. See, hydrogen. This is the first group of periodic table. Hydrogen, lithium, sodium, potassium, rubidium, cesium, and the francium. So these are the 6 elements which belongs to first group. That means, as I said, if we move from top to bottom, then that vertical part is called as a group, right? So we will see in group whether the size of element increases or decreases, right? So first we will see with the hydrogen. I will take only 3 example. After 3, when we will come to know whether while moving from top to bottom whether the size is increasing or decreasing. So it means in case of hydrogen we have only one electron, that means atomic number is 1. So that's why the electronic configuration of hydrogen is only 1s1. Why? Because we have only one electron. So that's why this first cell only not completed. So that's why we have restricted our electronic configuration for hydrogen with first cell only. So now if I write the atomic level diagram, then atom means there should be a nucleus, and now around the nucleus electrons are always revolving. See, I am just writing only one cell. Why? Because our hydrogen is having only one cell. Now, next, coming to lithium, 3, 1s2, 2s2, 3s1, 2s1, sorry, we have only 2s1, only 3 electrons. So therefore atomic level diagram will be again same: nucleus, first cell, and the second cell. We have, in case of lithium, we have 2 cells, so that's why I have shown 2 cells. Next, sodium. Again, already we know sodium is having 11, or the atomic mass of sodium is 11. So therefore electronic configuration will be 1s2, 2s2, 2p6, 10, and 3s1. So therefore in case of sodium we have moved till third cell. So therefore first cell, second cell. In second cell we have 2, that means 2s and 2p suborbits. So therefore in the end the last electron is moved into third cell. So that's why I am again writing the third cell. So now you just see these 3 diagrams, right? So in hydrogen, what we are seeing the size in where? In the group. So now atomic radius is nothing but the distance between the center of the nucleus to the outermost orbit. Now what is the size? This much. That means the hydrogen, they are in the same group. Consider first in hydrogen group, we say directly hydrogen group. So in hydrogen group the size of the hydrogen is this much. In the same group, if I move down, one element down, there is a lithium, and now in lithium, what is the size? Comparing with the first element of the same group with the second element, then the size is bit increasing. Again, if I come down to the sodium in the same group, now what is the size? As compared to the lithium, again the size is increasing. In the same way, here in potassium we have fourth cell. See, that means this is the sodium size. Now the potassium size is this much. And again, rubidium. If I move down one by one element in the same group, what is happening is our size, that means the radius in group while moving from top to bottom, it is goes on increasing, right? So which is very important. Now see, from hydrogen to lithium we have increasing in the size. That means from lithium to sodium, again little bit the size is increased. Why? Because the electrons are, see here the difference, electrons are moving into the new shell. See, in the first element we are restricted with the first cell itself. In the second element, in the same group of second element, we moved into the new shell, that is 2s, second cell. In the same way, sodium, that means third element of the same group, if we see, we have again moved into the new shell, that is third cell. Likewise, here we can see fourth cell, fifth cell, sixth cell. These all are S blocks, so that's why the last electron will enter into the S only. So on that basis, I am writing directly, that is in potassium we move into the new shell, that is 4s. In rubidium we move into the new shell, that is 5s. Again in the same way cesium 6s, and in the francium 7s. So therefore, what is happening in the group is nothing but, while moving from top to bottom in the same group, the size or the atomic radius is increasing. Why? Because our electron, reason is very important, because while moving down the group by element by element, the electrons are moving into the new shell. So that's why our cell size is increasing even though they are present in the same group. So this is about group, right? If if you are not understood any part from this group of atomic radius, then please comment me. Why? Because this part is very important. This is the I took only one simple example for one group. If you the same thing, if you put into the other groups, then definitely you will see the increase in the size. That means in group always atomic radius increases while moving from top to bottom, right? So this is about atomic radius in the group. So now we see in periods. So the second property of periodic table is period. So not only we have to see atomic radius or ionization enthalpy or electron gain enthalpy in case of group, as well as we have to consider periods also. So periods are nothing but horizontal group, right? I said horizontal. That means left to right. If we move from left to right in the periodic table, then that particular point is called as periods. So I will write one period: lithium, beryllium, boron, carbon, nitrogen, oxygen, right? Fluorine and neon. We don't need this, but it is complete one period. That means, according to the definition of periods, if we move from left to right in a horizontal manner, then that is called as periods. So that means consider this period. Now I will write directly 3 atomic number: 4, 5, 6, 7, 8, 9 and 10. Now consider lithium again. Lithium, we are going to see in period whether the atomic radius increases or decreases. So now lithium, again 1s2, 2s1, second cell. Now beryllium 4, 1s2, 2s2, 2 plus 2 4. So therefore atomic level diagram will be like this. Now again you take boron, next element boron 5, 1s2, 2s2 to p1. So now this is very important. Okay? See, we no need to write one separate cell for S and one separate cell for P. Why? Because in second cell, very importantly, in the last video I said in second cell we see two subcells, those are S and P. In third cell we see three subcells, S, P, D, and in fourth shell we see four subcells, those are S, P, D, and F. So this is very basic point. So now after seeing these three examples in the period, what we are observing here is nothing but the electrons are moving into the same cell and our size is not increasing. Why? Because the cells are remaining same. Like in group, what we saw is while moving from one element to other element down the group, what is happening? What was happening? The electrons are moving into the new cell. But here, in case of period, the case is different. The electrons are moving into the same shell. That means that is in second cell only. So that's why here what happens? See, electron is nothing but we in the first class we saw they have their particular mass. So that means here in second cell, how many number of electrons are there? Only one. Here 2. In this completely you see 2 plus 1 3. See, in this case in the lithium we have only one electron at the outermost cell. In beryllium we have two electrons. That means as we move from lithium to fluorine or neon, the number of electrons are increasing in the particular of second cell, right? In particular second cell, the electrons are increasing while moving from left to right in the period, right? So that's why what happens, because of increasing the number of electron in the same cell, the cell starts shrinking, right? The cell will start shrinking. So that's why as we move from lithium to fluorine or neon, the cell goes on decreases, right? The cell goes on decreases. Why? Because we are putting more electrons into the same cell. So that's why what is happening? Our cell is shrinking. So what is the conclusion we draw in the period about atomic radius? Always it is decreases, because the reason is because the electrons are entering into the same cell. You can take a carbon example also, right? 6, 1s2, 2s2, 2p2, nitrogen 7, 1s2, 2s2, 2p, 2 means 3. Why? Because we have 7. Oxygen 8, 1s2, 2s2, 2p4, fluorine 9, 1s2, 2s2, 2p5, and finally if you see the neon 10, 1s2, 2s2, 2p6. See, from here lithium to neon, if we see the last cell, that is same, that is second cell. So that's why what happens in the period is nothing but if you take any period of the periodic table, the same character we can see. So that means atomic radius always decreases in the period, and the atomic why? Because the electron enters into the same cell. But in case of group, what we saw is the atomic radius always increases in group. Why? Why? Because the electrons are moving into the new cell. So this is all about today's class. In the next class, we will continue the other characters of the periodic table. Thank you.